This is day 2, session 4 of the Instron Biomedical Testing Open House, Test Method Optimization, Getting the Most Out of Your Software. Thank you so much for being here. I'm Nick Erickson, your host for this session. For this discussion, I'm joined by 3 of our application engineers, Meredith Bernstein, Dan Caesar, and Landon Goldfarb. They'll be leading this discussion to highlight some tips and tricks for streamlining and improving the testing process, from data entry to analysis of results. Before moving us into more of an open discussion where they'll take some questions. As an application engineer, this group works closely with customers to make equipment recommendations and prove out solutions. For example, a customer might send Meredith a material sample and let her know they're having trouble with specimens slipping out of the grips. So then Meredith would then take that sample to our applications lab and run some tests comparing effectiveness using different grip types, jaw faces, maybe extensometers, and then go back to the customer with a report of recommendations, which might be an out-of-the-box solution or something a little more custom. This team will use about half of this session to present some of their tips and tricks, and then we should have plenty of time for questions at the end if you have some. So please use the chat box on your GoToWebinar panel to submit any relevant questions you might have as we go along. One last thing I do want to remind everyone of is that Essentials of Biomedical Testing e-learning course that we offer, the single-use free code. This is just a quick reminder that you'll want to complete the post-event survey that will display immediately following this session. And I will be sure to remind you again at the end. So with that said, I'm going to turn things over to Landon.
Thank you, Nick. Good afternoon, everybody. And I'm glad you could join us for our session on test method optimization, really trying to get the most out of your software and have the most advanced method development that you can. So for today's session, we're going to be spending some time talking about the different aspects of method optimization. So data input, test workflow, analyzing results, and data exports and reports. Then we'll be combing through some of the most commonly asked questions from customers to us, to our sales staff, to our tech support, really the most commonly requested items. And then, as Nick said earlier, we're going to finish off with hopefully a really in-depth Q&A about any topics you may want to discuss. We'll have the software available so we can always walk through it live in the software. So any questions you may have, we'd be happy to take them. So first, we're going to walk through data input. Often, really the most overlooked process during testing. A well-conceived testing procedure and setup can be completely overshadowed by a time-consuming and error-prone data entry process. Especially in quality control testing, there are generally several parameters about the sample and specimen which need to be recorded at the time of testing. Many companies utilize text inputs because it's what they're used to and it's what they've always done, forcing operators to manually enter data for each specimen. The total test cycle time includes data entry, specimen insertion, actually running the test, and specimen removal. Just for an example, let's imagine a test on a brittle material, which may only take 20 seconds, while the actual data entry associated with that test may take 30 seconds, putting in all the different operator inputs. If you're able to reduce the data entry time to just 5 seconds, over the course of an entire year, you could test almost 30% more specimens. Unsurprisingly, manual data entry is a large potential source of errors. An error in entering a specimen dimension could result in a lower modulus or tensile strength, causing a material to actually show up as out of specification. An error in a batch or a lot ID, I apologize, batch or a lot ID could cause an issue where the results are improperly exported to a LIMS system. The downstream effect of these errors could be as drastic as holding up release testing of a batch, resulting in a delayed shipment and required retesting, ultimately costing the company money. Repetitive data entry can cause increased operator fatigue as well, which also has its own significant knock-on effects within the lab, causing a decrease in productivity. By reducing data entry time, the operator in turn has more value-added time to either test more specimens or work on alternative tasks. Operator fatigue can also be strongly linked to reduced morale and eventually increased employee turnover, a costly metric requiring training and onboarding resources. Barcode scanners are an easy and relatively low-cost solution for reducing data entry time. Most off-the-shelf barcode scanners with a USB connection are designed to be plug and play. In this case, meaning they can be used immediately after installation. There is no specialized module or setting needed within the software either. They can be integrated with Bluehill instantly once 2D or 3D barcodes have been generated. 3D barcodes, or more commonly known as QR codes, can hold large amounts of information and should be utilized for longer text strings. Typically, long alphanumeric strings such as a batch ID or a lot number are ideal candidates to be barcoded. The barcode scanner greatly reduces the chance of operator error. Depending on the type of barcode scanner, they can additionally be programmed to automatically jump to the next available field after scanning, removing the operator need to click into the next field. While this may seem like an insignificant task, an insignificant amount of time, over 500 to 1,000 specimens, you can shave off minutes or even hours. On the next slide, we can see a barcode scanner in action, showcasing how simply it can be integrated into your test procedure. So you see here, scan it, and it immediately populates the lot ID. And as you can see, this would be a very tedious and time-consuming string of numbers to have to type in every time. When discussing data entry with customers, often the most underutilized feature in Bluehill is the choice input. The choice input is ideal for data entry involving predetermined and limited number of inputs. This can be used to expedite the input of specimen geometries, batch numbers, operator names, test speeds, and many more. Choice inputs offer many benefits, most namely faster data entry times and fewer opportunities for text entry related errors. The full capabilities of choice inputs can be recognized when they're used in conjunction with linked values. These are associated specimen properties or number inputs which will automatically change with a choice input. This example in the video here uses the new auto position feature in the 6800 systems to automatically adjust the crosshead position to the correct starting location for each specimen size. So this prevents any user error from improper specimen insertion, as well as reducing the total test time required for each test. Another use case is for selecting the test speed via choice input. This can be really useful in R&D scenarios where the method development is ongoing. By selecting the linked value icon, the operator will see all available options for linking. Some of the more common linked values are test speed, specimen geometry, preload values, and a number of additional specimen identifiers. This functionality can often reduce the total number of test methods required, reducing the work needed for method development. Next, we will look at test workflow, which we can generally define as how an operator runs a test. The individual steps are often captured in an SOP, but a combination of training and experience are often needed to avoid missing or incorrectly performing a step. Industries with high employee turnover or seasonal employment tend to need frequent training for their new operators to ensure testing is being performed properly. Additionally, increased oversight will often be needed to certify the tests are being performed correctly. In many instances, the repeatability of results can be affected by the specific operator. More often than not, this lack of precision can be attributed to improper specimen insertion or faulty data entry. These issues are generally very difficult to track down after the fact and can have far-reaching consequences if the product falls out of spec. Retests and delay of shipment affect both the bottom line and even potentially the company image. Finally, issues can arise when operators accidentally change or delete a test parameter outside of the required test procedure. These modifications could be minor, like changing a graph axis or a font size, but could be major, such as changing a test speed or a calculation. A change of that magnitude would disqualify most quality control testing and necessitate retests. Within Bluehill, the workflow functionality can mitigate the risk of each of these issues, simply walking operators through a pre-programmed test procedure. Within Bluehill Universal, any method can be enabled as a prompted test. A prompted test is a predefined procedure an operator is required to follow while running a sample. Once it is enabled, the user has the flexibility to edit the allowable sample size and the necessary prompts for the operator. In many quality control settings, the sample size is predetermined, and enabling this predefined sample size will automatically cause the sample to finish once all of the specimens have been tested. The toggle boxes each correspond to an operator interaction with the system, which may or may not be needed for your particular test. Start sample is typically always needed and will ask the operator to enter sample-specific information such as their name, batch number, or the lab environmental conditions. As a lab manager creating the workflow, they have the ability to add editable instructions, which can often be pulled directly from their SOP for consistency. Required test parameters, which are defined within the method, as well as a picture, which can be extremely useful for highlighting the proper test setup. A visual aid for operators to confirm that their fixturing is set up correctly reduces the chance of inconsistent data. Before test will include all specimen-specific parameters, such as geometry and specimen ID. In this instance, a picture was added in order to show the optimal test setup. This photo can easily be added and selected by going to the folder icon. Less commonly used, before analysis is needed for certain calculations which require an input from the operator, such as a cursor selected point or selecting a failure mode. Test notes is plainly a prompt to add any notes about the test after the fact. This may be used for component testing, for example, where the failure location may change test to test, and this needs to be recorded. Finally, the finish section will most likely require operator input related to the export of the data, such as a sample name or an export location. To bring it all together, let's see the experience for the operator. I'm going to quickly share a video showing the operator's point of view walking through a prompted test. So I've sped up this video for the sake of time, but here we have the operator starting the test, entering sample information. Here on the before test, we have the correct fixturing as well as them entering the specimen information. Here we see the actual test running. And now we have a cursor selected point for the break loose force. Now for test notes, they would write if there was anything that happened that should be noted, such as some sort of failed test. And then you can see it would go right back to the next specimen. So now I'm going to hand it over to Dan, who's going to talk about results and analysis.
Hi, everyone. My name is Dan Caesar, and I will be focusing on test results, and I'll be sharing a few ways to improve your Bluehill test methods to better visualize and analyze your results. So again, here are some issues and their potential consequences. First, when a specimen is tested and Bluehill displays a result, it isn't immediately clear whether that result is good or bad, so whether it's within spec or out of spec. This problem is most common with production or QC test labs, where results are generally held to a tolerance, which is either written on an internal drawing or some sort of document that is kept outside of Instron software. This requires operators to find this information, which can take time and is prone to errors, especially if you have more than one product that you're testing. Another inefficiency many labs are unaware of is their statistical analysis process. Whether using Microsoft Excel or another software platform, many labs are accustomed to getting data from their Instron and then performing analysis outside of Bluehill. Involving multiple tools can be a waste of company resources, especially when adding up the time over the course of a year or more. Finally, when testing various samples in a single test method, it can be a challenge to sort the results by the parameter you want to sort by. And averaging the wrong sample's data can happen and has the potential to cause needless product recalls or production stoppages. Okay, so let's address the first issue. How can my operator easily know if a result is good or not? We suggest adding the PassFail Indicator to your workspace to make it very clear if a specimen is passed or not. Here is a similar test that Landon had set up with a syringe. As one can see, this test is passed. The indicator can be moved to any part of the workspace. It can be made smaller or larger to your liking. Looking at the next specimen, we can see that it has failed. And when a test fails, the information icon can tell you a little bit more as to which result actually failed, because you can create acceptance criteria for more than a single result. And you can see in the results table that this same indication is shown with the result that has failed. For this particular test, the break loose force upper bound was consistently exceeded by compound C. Up next is, can I avoid calculating statistics manually in Excel? As shown in this screenshot of a results table, we can see that the mean, standard deviation, and coefficient of variation are all displayed. Most test standards do require statistics to be reported, so this is an easy way for Bluehill users to avoid the additional step of exporting simply to perform this analysis. This can be added within the Method tab, navigating to the Statistics section of the results table that you've configured. And it's worth noting that there are more statistics beyond the commonly used mean or standard deviation in case your laboratory needs that. The last results-focused optimization answers the question, how can you sort specimens by a shared parameter? Subsample is a feature within Bluehill Universal that allows users to group by a given parameter that is shown in the results table. For instance, in this case, C barrel lubricity compound. So compounds A, B, and C were tested in this sample, but calculating the mean value by combining all of the tests really doesn't provide what I'm looking for, because what I'm really interested in is analyzing each compound separately. To do so, I can click on the column header and these icons will appear. When pressing the boxes or the grouping icon, all alike samples will be grouped to form a subsample. Once the subsample is formed, operators can see the group statistics rather than the entire sample's statistics. To enable group statistics, make sure to right-click on the results table and ensure that it is shown. So that'll be it for results, and Meredith will take it from here.
Thanks, Dan. Hi, everyone. This is Meredith. In this section, I will be focusing on a few ways to optimize and improve your data exports and results using Bluehill Universal. This is the third phase of the overall method optimization we've been walking through, starting with testing, results, and now exporting those results. Again, we will look at a few common issues and their potential consequences. In general, we've found that reports, exports, and report templates can be underutilized or sometimes unknown functions of Bluehill. Like many of the topics we have discussed today, a simple initial setup process can save a lot of time down the road and ensure greater efficiency and consistency. The first issue that we'd like to highlight is that operators produce reports that are not consistent in their content or their formatting. This is problematic as reports containing varied information or missing information can slow down production, and it is time-consuming for operators to recreate a report each time testing is performed. The second issue that we see is test files that are not saved with a consistent naming structure or to a single location. This leads to delays as other operators go to use the same files and can't locate them. Also, there's a quality issue that can lead to problems during audit if files are not clearly and consistently saved and labeled. The third issue that we see is results are manually input into Excel or a LIMS system. As we've mentioned a few times, any sort of manual data entry is much more likely to lead to mistakes and is also vastly time-consuming. So let's dig into these issues a little deeper. To address our first question, how can I ensure consistent and complete reports across operators? Like a method or a sample file, all parameters set up within the Reports tab can be saved as a report template file, which can then be used for any method, just like the way a method file can be used across multiple samples. These parameters are broken into several sections, including the header, which is customizable with date and time, company logo, page numbers, among other pieces of information. And as you select your preferences, you can immediately see them previewed in the panel on the right-hand side of the screen. There are similar settings available for the footer section. You can include date and time of last test, the user who performed the testing, and other options. And again, this immediately appears in the preview on the right-hand side. The content within the body tab makes up the meat of the report. This is where you select graphs, results, your method description, and method parameters that are to be included. Method parameters include values like test rate or end of test criteria that are not results, but are often required to be reported. One trick I wanted to mention is the best fit toggle for graphs and reports. So here is what the report preview looks like when the toggle switches off. As you can see, you can manually adjust the dimensions, which is time-consuming to do for every report. And now, here is what it looks like with the toggle on. This one button click lets the software auto-fit the graphs for you, and it makes the report look a lot cleaner and more organized with very minimal effort on the part of the operator. You just toggle it once before you save the report template and don't have to worry about formatting again. It's a really easy way to ensure all graphs and results are clearly displayed. Report templates are saved just like any other Bluehill file in the upper right-hand corner, and like I said, are incredibly valuable because they can be applied to any method file. The next issue is, how can I ensure test files are always saved to the right location? This option is available within the Method tab under Exports File Settings. On this screen, you can specify a default folder to save all output files. This includes the report, sample file, and any data exported. You also have the option on this screen to type in a sample file name, so all samples run with the same method will save with the same name, and you can append the date and time to the end of the file to keep track of different batches of testing. Within the method, under Exports and Reports, you can select the report template to be applied to a given method. You simply save the method, and every time a sample is run with this method, the report template is automatically applied. Also, on this screen, instead of just saving the report after finishing a batch of testing, you have the option to print or email the report every time a sample is completed. Depending on your lab's process, this saves the manual step of having to inform a manager or supervisor that a given report is ready. And now our third question, how can I automatically export results and sample file data directly to Excel? Within the test method, under Exports and then Exports 1 or 2, you'll find all the settings available for customizing what data and results get exported directly to Excel. Within this screen, there are two sections of customizable options that I want to highlight. The first is for the actual data that gets exported. In this content menu, you can select which results tables are exported, whether you export sample or group statistics like Dan talked about, and if you want the method parameters exported as well. Like with the report template, all of these selections are immediately previewed on the right side of the screen. And I want to highlight that this menu is where you can select to export the raw sample data. We get asked about this fairly often, and it's simply a toggle that you have to worry about setting up only once. The other section of customizable options related to exports is under Export Settings. Under this menu, you can select when all files are exported. It's typical for methods that use prompted tests to export at finish. When all specimens within a prompted test batch are completed, the relevant files will automatically be exported to the designated folder. The other options here are after each test or on demand. Within this menu, you also have the option to override the destination folder you set in the File Settings tab. If your data needs to be exported to a different location from where your report and sample files are saved, for example, for a direct integration into a LIMS system, this is where you can set that up. And finally, this is where you have the option to save a specimen as its own separate file if this is more convenient for your results processing. That wraps up our method optimization recommendations from start to finish. And now I'll hand it back over to Dan to kick off the questions section.
All right, thank you, Meredith. So before getting to the live Q&A session, as Landon said at the start, that we thought it would be worthwhile to answer a few questions that our tech support team frequently receives. I also want to give everyone a reminder to continue to type specific questions into the question panel, and hopefully we can get to them in a few minutes. Okay, so the first FAQ involves confusion around two available measurements that sound very similar: displacement and tensile displacement. Displacement is always linked to the crosshead's position and movement during a test. This is different from tensile displacement, which is linked to your strain source. If your test method uses an extensometer to measure strain, this is the displacement that the extensometer is measuring. With an extensometer as the strain source, there is no link to the crosshead position. When an extensometer is not being used to measure strain, your system's strain source will be the crosshead's change in displacement throughout a test. So in this case, tensile displacement is linked to the crosshead's movement. So here you can see the measurements that I'm referring to, that we have displacement here, tensile displacement below, and displacement is referring to the crosshead always, whereas tensile displacement is referring to your strain source. So if your strain source is an extensometer, there is no link between tensile displacement and the crosshead. But if you aren't using an extensometer, then your tensile displacement will be linked to your crosshead position. Another common question is how to change dimensions after a test has been run. It can be easy to forget to enter dimensions, especially if you're not using workflow. And depending on how your method is configured, operators might be locked out from entering dimensions after a test. If you want operators to be able to edit parameters of tested specimens, the operator inputs can be modified to allow changes as shown in this screenshot. Each parameter in operator inputs can be customized to prevent changes in any of the 3 testing states. Many labs do require this to be locked down because they don't want their operators to accidentally modify dimensions, which can invalidate test results. However, if you are okay with giving your operators this ability, it can be enabled. The last FAQ today will be why the reported gauge length is different from the value that is entered. This case can occur when your test does not use an extensometer and the software uses the length parameter or distance between your grips as the specimen's gauge length. Here is a test space where you can see the entered gauge length was 25.4 millimeters. However, looking at the results, all of the reported gauge lengths are slightly greater than 25.4, and they are not consistent. Although the reason for this might not be immediately clear, the answer lies in the method's pre-test routine. To get rid of any slack in the specimen and to start the test at a consistent force, this method has a 25 Newton preload. And to reach this preload, the crosshead has to move to achieve the 25 Newtons of force. And because the crosshead has moved, the gauge length should be adjusted to reflect this change. This is done by auto-balancing the strain source, which gauge length is tied to. So using a preload routine and auto-balancing strain, which is very normal, it can adjust your gauge length that is reported, as each specimen will be marginally different. Okay, that's it. Hopefully these explanations helped at least a few people out. Much of what we just went through is obviously pretty difficult to remember. So obviously this is going to be available to watch through one more time. But I also wanted to point out to everyone to Bluehill's version of a manual, which is an embedded help file within the software. If you press the question mark or F1 on your keyboard, a dialog box will appear and any part of the software can be searched. For instance, this screenshot explains how auto balance works. Beyond this, whenever I am unsure of a calculation or any other part of the software, the help file is always the first place that I look. Here you can see a particular modulus calculation is explained, its algorithm is provided, and even a visual example is shown. And with that, now it is time for your questions, which Landon and Meredith will be answering for the remainder of the session.
Thanks, Dan. So we're going to go through some of the questions that have the broadest appeal to the audience, and anything that we don't get to during this section, we will absolutely reach out to you independently to go over how we can help fix this for your specific application. So one of the first questions we're going to look at is, can you edit the choice inputs after you've started testing in Universal? And this is something you could not do in Bluehill 3. And that in Universal, that is still the case. There are certain parameters that you have the ability to edit once you've started testing, but choice inputs are not one of them, as they could potentially change the actual functionality of the test. Going to the next question, is there a way to allow you to continue testing if you get to the last sample in a prompted test, but end up having more samples? So this is a question we get a lot. And typically, if you use the predetermined number of specimens in a sample with a prompted test, it will there's no ability to add an additional one. If you know that there is a potential need to add specimens at the end of that run of tests, the best solution is just to keep it as an open-ended prompted test where you're not limited to a set number. You do have the ability to exclude specimens and have them not count as a number, but as far as adding after the fact, you are not able to do that how the software currently works.
So what other statistics can Bluehill calculate? So these are all within the workspace tab and results. And if you go to statistics, you have the option to add a coefficient of variation, maximum, mean, median, minimum range, standard deviation. And like Dan pointed out, these can be calculated for all of the specimens run within one sample, or these can be calculated for specimens that have been grouped based on a specific test parameter. Our next question was, how do you make new report templates or edit one? So Landon, do you want to walk through this in Bluehill?
Sure. So Meredith had gone through most of the steps during her section of the presentation. But if you were to open up a sample file, I apologize, I have a lot of apps open, right? So it might be taking a little bit longer. So you are always able to go to the report tab, and if you have a default template, you would choose it in your report section of the exports tab. So here is where you would actually choose a template. These can all be saved locally, and then once you save it, you always have the ability to edit it, and you just have to simply hit the save button, and you can save it as a totally new template, or you can just save it over the existing template. And as Meredith discussed, all of these different options with the header, body, footer can all be changed. So the next question, is there a way to have an option to automatically format a report for complying with certain regulatory standards? Say, for example, the formatting and relevant information. So we do have application modules which are for specific standards. They're not necessarily to a regulatory standard. So for example, we have pre-existing standard methods that exist for 7886-1 for syringes, which is what this test is. And that would come with a report that has all the information as required by the standard. There's no way to hit some sort of choice input that goes to a regulatory standard and it will automatically format the report to that regulatory standard. But once you create it and save it, you can use it across all of your methods, all of your samples. So it's not like you need to make these changes over and over and over again.
So our next question is it possible to save the report in more than one location based on a choice input? No parameters that are within the report template are anything that you can change via a choice input. So within your method, you would select one location that the report and all of the exported files would be saved to.
So the next question, how does the system calculate transverse strain? So really there are a couple different ways you would need some sort of transverse extensometer. So really the options would be a transverse clip-on, a biaxial clip-on, which could do both axial and transverse measurements, or the AVE, which is the advanced video extensometer, has a transverse option, which could measure 2 dots placed along the width of a specimen. And the Auto X750, which is our automatic contacting extensometer, has a biaxial attachment, so it could also measure transverse strain. So there are a lot of different options as far as extensometry are concerned to get transverse strain of a specimen.
The next question is, can we use 2 or more of the choice inputs as a report file name? Again, none of the parameters within the report tab cross over to the choice inputs that you've selected. So within that report file name, you can't directly pull from your choice inputs.
And then finally, can we change the settings so that the software will pull the report template from a different folder? So when you go to the report template, you can choose the folder icon, and you can choose any file location that you'd like to always pull from. So you could have a local folder that's just your pre-configured report templates, and you can always have it pull from there. And then Bluehill will also automatically make a local folder, so the Bluehill Universal templates folder, where they're all going to be held by default. If you decide to keep it somewhere else, you would just have to choose that file location separately. But it looks like that's all the questions we have. Any we didn't get to, we'll reach out to you offline to discuss. But I think if that is all the questions, we'll hand it back over to Nick, who is just going to finish up and talk about what's coming up next.
All right, thanks, Landon. And if you don't mind, jumping back over to that PowerPoint so we can show everyone what's kind of coming up next. Like Landon said, this is going to do it for today, but I do want to leave you on a few quick notes before we wrap things up. We do hope that you'll join us tomorrow for another full day of great presentations, which you can see here. If you'd like to attend any of these but aren't currently registered, just head to instron.com now to sign up. I'm also going to drop a quick link into the chat that goes direct to our event page, make it nice and easy for you. The recording from this session will be available on our YouTube channel shortly, and each of you will also receive an email with a link to this recording. And then just another quick reminder about receiving the single-use code for free access to the Essentials of Biomedical Testing e-learning course. In a moment when the session ends, a survey is going to pop up and there will be a question related to this. You just need to indicate whether you would like access to this course. With all that said, I just want to thank Meredith, Landon, and Dan for a fantastic presentation. And thanks to all of you for attending. We do really appreciate your time, especially all of you that attended multiple of our sessions so far. This is really great. We're happy to see you all join us. We do hope to see you again tomorrow at some of our upcoming sessions. And that's all we have for you today. Take care, everyone.